start with organic chemistry conversion of reactions and their types. Benzene blend reacts with concentrated H2SO4 and concentrated HNO3. This mixture is known as nitrating mixture. The purpose of reaction is to put an electrophile, which is nitronium ion, on the benzene ring. So this is what type of reaction? Electrophilic aromatic substitution. This nitrobenzene, when treated with the metal with the mineral acid, is converted into an amine, aromatic amine, that is aniline. Aromatic amine on treatment with NaNO2 and HCl at 0 to 5 degrees Celsius. The purpose of this mixture is to furnish HNO2, nitrous acid. This will produce diazonium salt. This is known as benzene diazonium chloride salt. This is aniline. This is nitrobenzene. Benzene diazonium chloride salt on treatment with water produces phenol. Phenol on further treatment with zinc dust and heat produces benzene. So let us find the utility of these conversions. See, the trick is what? Starting with benzene, we are finishing the line off with benzene. For example, if you are asked to convert nitrobenzene into phenol, then how will you proceed? Nitrobenzene into aniline, then into diazonium chloride, then into phenol. Have you found? If you want to convert from nitrobenzene to phenol, so this is the way out: nitrobenzene to aniline, to diazonium chloride salt, then to phenol. If you are asked to convert phenol into nitrobenzene, how will you proceed? Phenol to benzene. That means you are here. Then you can proceed to nitrobenzene. Have you found this trick? Now if you are asked convert aniline to phenol, how will you proceed? Aniline to diazonium chloride salt, then to phenol. And if you are asked from phenol to aniline, then how will you proceed? Phenol, then to benzene. That means you are here. Correct? Then you proceed to nitrobenzene, then to aniline. That means this is a one-way traffic. You can close the chain right there with here. And accordingly, this whole conversions can be carried out tactfully. Yes, your question?
Sir, I want to understand that nitrobenzene and
Iodobenzene? Nitrobenzene?
into aniline.
Tin with HCl, SN/HCl. If you reduce nitrobenzene by a metal with a mineral acid, it will be converted into aniline. Correct?
Sir, any metal can be used.
Those who are above electrochemical series in hydrogen. This is toluene. Chromyl chloride will form benzaldehyde. Oxidizing with KMnO4, you will get benzoic acid. You add soda lime and heat it, you will get benzene. Now you see, some more functional groups have been introduced in this chain. First is the alkylation, and then formylation, that is aldehyde group has been put on the benzene ring, and then subsequently carboxylic group, and finally we have terminated the chain with benzene. That means if you are asked to produce phenol into benzoic acid, how you will proceed? From phenol into benzene. That means you are right here. Then you start with alkylation and subsequently you can proceed up to benzoic acid. Have you found? Can you find the utility how you have to manipulate this whole table while converting a certain species from aromatic one ring substitution into another form? CH3COCl anhydrous AlCl3. That is acylation. This one is alkylation and this is acylation. The component you are getting is acetophenol. Correct? You will get COOH. With acetophenol, directly with potassium chromate, we will get benzoic acid. And you know how to decarboxylate benzene ring. Benzoic acid, how you can decarboxylate it? By simply heating with soda lime. Have you got it? Any queries so far? We can introduce some more functional group right after this benzoic acid. What are they? PCl5. We get COCl, benzoyl chloride. And then with this NH3, we will get benzimine. And then with this P2O5 added, we will get benzene nitrile, which on subsequent hydrolysis can be changed into benzoic acid. So let us find the utility of this further extension. Actually, we have taken these all functional group in our consideration. If the examples gives you, how will you convert nitrobenzene into benzamine? Nitrobenzene into benzamine. Nitrobenzene you can convert it into the benzene, right? Then you can proceed in that way to benzoic acid and then to the benzamine. If you are in need of this functional group in your substitution, then you follow this path. Otherwise, you can close the chain right here from the benzoic acid to the benzene. How will you do that? By simply treatment with soda lime and heat. Have you found? For example, if the question gives you, how will you convert acetophenol into benzene nitrile? How will you proceed? Acetophenol, benzoic acid, benzoyl chloride, benzamine, and then benzene nitrile. But if the question asks you acetophenol into nitrobenzene, how will you proceed? Acetophenol, benzoic acid, from benzoic acid to benzene directly. How will you do that? By simply treatment with this soda lime. You will get what? Benzene, and that benzene will be converted into nitrobenzene. Have you found when to proceed this path? If you are in need of this functional group, then only you extend this COOH into this all format. Otherwise, you can close the chain right over here. Now, so far, whatever we have discussed, we have got some name reactions. This reaction, that means alkylation or acylation or the benzene ring, that is known as Friedel-Crafts reaction, and that can be carried out in presence of Lewis acid. Here it is anhydrous AlCl3. Another important name reaction that we have come up is that toluene into benzaldehyde. This reaction, it is known as Ettard reaction. This reaction is also known as Ettard, E-T-A-R-D, Ettard reaction. So two name reactions that we have already come to know. This reaction is known as diazotization reaction. Three name reactions: diazotization, D-R-A-Z-O, diazotization reaction. From benzene diazonium chloride, we have so many paths open for us. Cu2Cl2/HCl. This will give you chlorobenzene. Now this chlorobenzene, this can be also carried out for Cu2Cn2/HCl cyanobenzene. This reaction also possible for bromobenzene. So chlorobenzene, cyanobenzene and bromobenzene, they can be prepared from diazonium chloride directly from Cu2X2/HX, where X stands for Cl, Br and Cn. This reaction is also known. This reaction will also be extended into formation of phenol, where H2O, H3O plus, high temperature plus pressure, first to the phenate salt and then subsequently hydrolysis, that will lead to phenol, that will produce phenol. And from phenol into benzene, you know the path, which is what? From phenol into benzene, zinc dust, it will terminate into the benzene. Now we have introduced halo group also over here. For an example, if you are asked to produce aniline into chlorobenzene, how will you proceed? Aniline, diazonium salt, from diazonium salt to chlorobenzene. If the question asks you from chlorobenzene to nitrobenzene, how will you proceed? Chlorobenzene to phenol, phenol to benzene. How will you do that? This way, and then to nitrobenzene. So can you close the ring in that way? Similarly, Cu2Cn2/HCl, that will give you cyanobenzene. We have already come to know about cyanobenzene right over there. Instead of going that much detail, you can directly produce cyanobenzene following another path, which is this reaction. Cyanobenzene on hydrolysis, as you know, produces benzoic acid directly. And you know the rest, how you have to proceed. Here, so this is a comprehensive idea where the ring substitution on aromatic conversions, we can make it as useful. Let us take some practice problem. How will you proceed this? Acetophenol, right there. So acetophenol on oxidation, it will produce benzoic acid. Benzoic acid can be easily decarboxylated into the benzene. That means you are right there. From there, you can produce phenol in that path. Clear?
So do we have to memorize all this?
Of course, this is the trick. So how will you proceed? Let us recap again. First, you go through this part only. First line. That means benzene into nitrobenzene, then aniline, then diazonium chloride, then aromatic alcohol, and then again benzene you have converted it. So as to close this part, right? Now on benzene, we have alkylated in one section and acylated in another section. When we alkylate it, it gives toluene and then into benzaldehyde and then benzoic acid, and we have closed the path right over there. If you go through the acylation way, then you are onto the ketone, then Oxidation will give you benzoic acid. If you need this part, that we already have elaborated the utility of this part, then you can proceed to the acid derivatives, namely acid chloride, then acid amide, and then finally you can terminate it into the nitrile group, which on further hydrolysis produces benzoic acid, and this can be subsequently decarboxylated. Another way of extending this chain is from the diazonium chloride salts to the halobenzenes and cyanobenzene. Clear? So this way we can use this table as a comprehensive tool regarding different aromatic conversions, but provided this is a ring substitution. If you observe that all the functional group is directly attached to the ring, that means the ring substitution types of conversions can be easily taken with this help as a handy tool. Now see, if it is doubly substituted, let us introduce the double substitution group. For example, if you are asked to produce phenol into p-nitrophenol, phenol into p-nitrophenol. Clear? Now here is the principle of directive principle has to be taken under consideration. You know that nitrating mixture that results electrophilic substitution reaction producing nitronium ion, which undergoes what? A substitution with the H positive ion in the ring. Now this already existing OH group, it is what? What type of direction it will produce? What type of electrophilic substitution reaction it favors? Orthopara, which is OP directing group. We know that that's for the reason of resonance. Yeah. Now on phenol, if you give concentrated H2SO4 and concentrated HNO3, the nitronium ion that is produced will be directed to which position? Ortho, and then again derivative is para. But if they ask you only para, you have to mention only the para product. Ortho product makes no sense over there. Correct? Now the question is, if they give you metal directing, that means this product has to produce. Now here is a different situation. As you know, phenol is what? Orthopara directing group. That means it's no way that nitro group will be there in the meta position. If you start nitrating phenol, you are supposed to get what? Ortho derivative and para derivative. But the question gives you what? You need to have M-nitrophenol. How do you proceed it? It is very easy if you just visualize one tricky approach. See, if you do have nitrobenzene as your parent product, then nitro groups is what? A meta-directing group. That means it is easily phenol group that can be introduced into the meta position. So instead of starting with phenol, you start with nitrobenzene. Have you got this idea? If you start with nitrobenzene, that means phenol will change its what? Into nitrobenzene. Can you do this? How you do it? Phenol into benzene and then into nitrobenzene. Then you start nitrating. What will you have? If you start nitrating nitrobenzene, where will you find the nitro group? At the meta position. You will get the nitro group there on the meta position. Right? Why? Because nitro group is what? An M-directing group. Now this nitro group under reduction, if the nitro group is reduced by SN and HCl, both of them will be what? Simultaneously reduced. You need to protect one NO2 group. Just remember, for that you will use ammonium, yellow ammonium sulfide. This is a special reagent. You just remember this. Yellow ammonium sulfide will do what? This will do, protect one group and will reduce the another group. That means one NH2 will be produced. One NO2 will be converted into NH2. And then you will do what? NaNO2HCl, then it will be produced N2Cl. One will remain NO2. Another will be converted into what? N2Cl. And then on further reaction with HOH, it will produce what? M-nitrophenol. Got this idea? Now the same organic chemistry converts reactions to aliphatic. Aliphatic group.
Is there any trick to memorize all this?
Read writing only. You simply start writing as I already told you. First the top line, then the left one, then the middle one. That way you will memorize it. If you start writing. Now the similar approach can be introduced with aliphatic chemistry. Let us know how. Alkyne. It will produce alkene. And then alkane. Free radical halogenation into alkyl halide. Aqueous KOH will give you alcohol, and then KMNO4 will give you carboxylic acid. Correct? Now alkyne into alkene, and then into alkane, and then alkyl halide, and finally this will give you what? Alcohol, and then aldehyde, and then carboxylic acid. The reverse path can be followed in what way? See, oxidation is alcohol into aldehydes into carboxylic acid. So reduction we need LiAlH4. From aldehyde into alcohol, again LiAlH4. From alcohol into alkyl halide, PCl5. So what is the basic idea? The basic idea is what? Just see, carbon number remaining the same. So this is not a step up, neither a step down. It is precise one reaction. PCl5 we will get CH3CH2Cl. From CH3CH2Cl we cannot produce alkane directly. Instead, you can go right there. That is by alcoholic KOH. Now you see one important difference. On alkyl halide, if you put aqueous KOH, you will get what? Alcohol. On alcoholic alkyl halide, aqueous KOH, you will get alcohol. But on alcohol, on alkyl halide, if you put alcoholic KOH, you get alkene. You just mention this difference. Take note of that. Rx on treatment with aqueous KOH, you will get alcohol. Rx on treatment with alcoholic KOH, you get alkene. Why? This is because of certain nucleophilicity or basicity to consider. We will come to the detail for the mechanism when it concerned. From this alkene to alkyne, bromine water, and then alcoholic KOH. First you add bromine water and then alcoholic KOH. That will give you what? Alkyne. So have you got this comprehensive idea? So how will you proceed? Alkyne into alkene, alkene into alkane, alkane into alkyl halide, alkyl halide into alcohol, alcohol into aldehyde, aldehyde into carboxylic acid. You remember this path. Here, let us take an example on this proceedings. For example, if you are given methane into methanol. How will you do that? Conversion is what? Methane into methanol. So where you are, into the alkane. You just remember it is alkane. So here you are. I have taken this table for alkene, ethane, 2 carbon. Why? Because we need alkene to produce, so we need at least 2 carbon. Now here you see what? Alkane, so you are with the alkane. Now the carbon are not remaining the same. First you observe, during conversion, the first priority that you will do is that number of carbon atom, whether it gets changed or not. If it changes, then accordingly you have to follow that path. We will show you where you can decrease, where you can increase. Just the next step will be ours in that discussion. Now for this example, alkane, so you can produce what? From methane into methyl chloride. From methyl chloride directly into alcohol intermediate. How? Methyl chloride into aqueous KOH, you will get methanol. Can you handle this table now for different examples? For example, if you are given HCOOH into CH3Cl. How do you do that? And you see what? You are right there. Carboxylic acid. From carboxylic acid into the aldehyde by the treatment with lithium aluminum hydride. So it will produce what? HCOOH. That will be converted into HCl. With that you can produce CH3OH. With that you can produce CH3Cl. Can you find the utility of these examples? So this table will definitely help you to convert the alkanes under questions. Clear? Now if you are given, produce CH3, C triple bond CH from CH3, CH2, COOH from propanoic acid to propane. How will you convert from propanoic acid? That means CH3, CH2, COOH, arrowhead. First you do lithium, aluminum hydride. You will get CH3, CH2, CH3, CH2, CH2. Then again lithium, aluminum hydride. You will get CH3, CH2, CH2OH. Don't forget to count the number of carbon atoms you are considering in your example. Here you have started with 3 carbon atoms. So from 3, then again into the 3, then again into the 3. This is very important. And then with that ECl5, you will get CH3, CH2, CH2Cl. Then you add alcoholic KOH. Right from this to that. Confirm? So you will get what? CH3, CH, double bond, CH2, propene. Now what will you do? You will add bromine water. You are right there. You add bromine water and alcoholic KOH to obtain alkyne. So how do you do it? Bromine water and alcoholic KOH. And then alcoholic KOH. You will get CH3, C triple bond CH. I told you what? In the unsaturation, 2Br will be, that is vicinal dibromide will be obtained. When you add bromine water in alkene, what happens? Vicinal dialkane is obtained. That vicinal dialkane on reaction with alcoholic KOH it produces HX short of removal and produces the alkyne. You got it? So this is some of this example that is very much useful while utilizing this table.
It's very clear to make alkane out of it.
Alkane, that is right there. Alkane. From here, if you are asked convert the propane. If you are asked propane from CH3, CH2, COOH, is that your question? Now what will you do? From there, you have produced this one, propene. You can easily what? Hydrogenate it. I have already told you. From propyl chloride to propene, but there is no restriction of going this way now. So you can easily convert it to the alkane. I told you what, you cannot come from this to that. You can come from this to that in a reverse path. But there is no restriction. by going from this to that again. So it is very easy. As you find propene, you can find propane by simply hydrogenating. Any query?
Sir, how does these topics give questions for entrance exams?
This topic is definitely treatment of the reagents, different reagents. They will give you certain reactions. There will be some question mark. For example, if I frame out this question, in that question, if I put over here a question mark and then give this to that, then you have to identify what type of reagent should be there. This is a reducing agent. LiLH4 is a reducing agent. So there will be options of several reducing agents, out of which you have to find out the better one that can be selected. Have you got? So this was the utility on some of those aliphatic functional groups. Now let us further extend this table from carboxylic acid. PCl5, CH3COCl, CH3COCl, acid chloride will be produced. Clear? This acid chloride on further treatment with ammonia will produce CH3CO NH2 amine. That is, this one is what? Acid chloride, and then we have found what? Acid amine. This acid amine, if you react with sodium in alcohol, you will get CH3CH2 NH2. If you react it with P2O5, you will get CH3Cl. If you react with Br2 NaOH, you get CH3NH. Now you see the difference between these two reactions. If you add Na alcohol, sodium in alcohol, you get what? One primary amine. If you add bromine NaOH, you get another primary amine. The difference between them is what? One carbon atom less. So in amine, if you add sodium in alcohol, you get same number of carbon amine. If you add bromine NaOH, you get one carbon less amine. This reaction is a step down reaction that I was pointing out previously. While in the given conversions, you should have a prior knowledge of from which to where you are actually converting. Clear? So during these conversions, if you are in a position to step it down, then this path is a better choice. For example, let us take now one example. Just one more step, then we will take this example. On primary amine, if you add HNO2, you will get alcohol. So how many carbon are there? One. So you get one carbon alcohol, that is methanol. So can you tell me what alcohol you are supposed to get when we treat it with nitrous acid? This one. How many carbon are there? So what alcohol is expected? Ethyl alcohol. So definitely you will get ethyl alcohol when treated with this. That means CH3, CH2OH. Clear? Now see the utility of this path. If you are given an example, convert ethanol to methanol. Have you got the question? Ethanol to methanol. That is what? You will first identify this one is being a step down reaction. Why? From two carbon atom into another carbon, another compound which contains one carbon less. Now how will you proceed? I told you what? This reaction will lead one carbon atom less. So this path has to be taken in blue. How will you do? This is ethanol to ethanoic acid to ethanamide, and then you can convert into methanol. Have you got the idea? Yes. From methanol to ethanol, that is a step up. From ethanol to methanol, this is a step down. Clear? So while stepping down, this Hoffman reaction, this reaction is what? Hoffman bromide reaction or Hoffman hypobromide reaction. Very useful tool for degrading one carbon. We will find some other pathway also where you can decrease the carbon number. There is another option. You can take NaOH oblique CaO and then 8. This is what? This is known as soda lime. When you hit with the soda lime directly, then you will get 1 carbon less alkane. 1 carbon less alkane. So if you are getting alkane, then where you are actually? You are right here. You can treat it in the same proceedings to produce different types of products. Clear? Another thing that we can do right over here is increase in the oxidation number, increase in the number of carbon. In that way, calcium hydroxide dry distillation. Here you get for acetone, which on reduction, zinc amalgam, concentrated HCl, you get an alkane propane. So here you get what? 1 carbon atom more. Why? You have started with 2 carbon atoms and it has actually ended up with 3 carbon atoms. And this reaction is known as Clemmensen reduction. Now, any number of carbon atom for the conversion purpose that can be done with Wurtz reaction. You know, you can produce this Rx that you have already come to know. This is Rx, and another Rx of your choice, which is R dot X. If you consider in dry ether and sodium, we will get R dash, another alkane of our suitable number of carbon. But remember, this is not of synthetic importance as it gives mixture of alkane. But for our conversion purpose, you can utilize the same. So this is all about the different types of conversions, including aromatic and aliphatic. Clear? Now a bridge. How can you change aliphatic into aromatic directly? Is if that you have already come to know that acetylene, copper tube, 600 Celsius, then you can get benzene. That means this whole table can be connected with the previous table, that is aromatic chemistry, by this simple equation. If you are asked ethanol into nitrobenzene, then also you can use this tool for these conversions. I hope this instruction is very clear, and for the solving of different types of conversions, irrespective of their standard and scope, so you can have a better practice of that cell, and we will come up with the next lecture on different types of mechanism. Thank you.